There are 3 goals for the French pilot. The first one is to reduce the energy consumption from the customer. The second is to reduce the impact of the energy transition. And the third one is to maximize the consumption of local renewable energy.
In this use case, we will test how dynamic tariff can help shift consumption to the most favorable time periods for the grid, and at the same time enabling users to benefit from it if they can be flexible. So to achieve this, we will test a control system that is based on interoperable data exchange with other interconnect partners, and that will control heaters, water heaters, appliances, and electric vehicle charging stations. Today, we are at a participant home where 4 heaters have been installed with the water heater and can be controlled based on the dynamic tariff. Every day, the participant receives the tariff for the next day, and they can act on their equipment to shift them to the lowest tariff possible, and what is controlled by the system is shifted automatically.
The service of the Smart Orchestrator is based on these preferences that the customer sets up and the dynamic tariff. We have algorithms that are able to find when, at which points, the user can save money. As you can see in the graphs, we can compare the dynamic tariff with the set points, and in the blue lines, you can find areas in which the user can set up the temperature a little bit lower in order to save money. Same in the second diagram, where the user is teleworking with another different type of set point and another way of saving money. These recommendations are given to the retailers or to the equipment providers in order to actuate on the equipment. One important point of this service is that thanks to NAD's platform, we will not reach the subscribed power in order not to have blackouts at home.
In Interconnect, for linking smart meter to transfer dynamic data to NAD's experimental platform, the customer simply needs to add a radio equipment to his smart meter that transmits real-time data to an associated gateway. Then, the customer connects the gateway to the Wi-Fi of his internet box as he does for any other connected equipment at home. Thus, metering data is transferred in real time to the NAD's platform according to the customer consent. The data can be retrieved via API by service provider to develop new innovative services.
I'm expecting from this kind of test to be able to quantify the reductions in my bill, and also how this reduction will impact my comfort, for example, in terms of heating temperatures. So this is the most things I'm expecting from these tests.
Another use case to be demonstrated in the Interconnect French pilot is the maximization of local renewable energy sources, which aims to maximize the self-consumption using a local energy community. The pilot is in Le Pradé with a photovoltaic plant and an electric vehicle charger from Wireline.
To maximize the consumption of local renewable energy sources, several smart appliances within the local energy community are remotely controlled and coordinated with the interoperability framework. The different steps of the service are: step 1, the customer subscribes and sets its preferences to the self-consumption and device management service. Step 2, the smart orchestrator receives a signal that indicates there is a local renewable generation available, and the message is sent to all MESs and smart appliance backends to consume as much as possible. Step 3, when the surplus of PV generation is no longer available, a message is sent to each EMS to come back to dynamic tariff operation. To encourage the consumption of renewable energy, every consumer and producer is rewarded with Green Coin.
Alors en quoi le projet est-il innovant? Ça aborde notamment le sujet de l'autoconsommation, c'est un des sujets qui est abordé au travers du projet, et ça aborde aussi la question, au-delà de l'autoconsommation, de l'équilibre des charges énergétiques en fonction de la production d'énergie locale et la répartition de cette énergie locale sur l'ensemble des utilisateurs. Donc ça permet d'équilibrer les charges énergétiques et d'économiser à terme de l'énergie, et on voit que c'est un sujet qui est vraiment d'actualité aujourd'hui.
The trialogue EMS TEMS provide a graphical user interface to monitor all EV charging and also provide the end user with the ability to give its EV plug and unplug time estimation on a daily basis for charging. You can display all the charging stations over the same period of time to get the current status as well as more detail to check, for example, the history of consumption of a specific charging station.
ThermoVault offers a retrofit solution that transforms heating appliances into flexibility and energy-saving storage devices. On all the installed households, ThermoVault is currently performing energy efficiency to reduce energy consumption. On top of this, more complex services are applied that need the interconnection of several applications and devices. This is the case of maxers or peak shaving services, where the SO can modify thermal loads consumption with no impact on the thermal comfort.
There are three values for the customer. The first one is to benefit from the smart meter and the interoperable tool to measure consumption in real time. The second benefit is to avoid the increase of energy costs with the flexibility. And the final benefit is to test new energy uses and be part of the decarbonation of usage. There are innovations in the French pilot. The first one is to pilot appliances from different suppliers according to dynamic tariff or local renewable energy. The second one is power limitation in order not to have any blackout with the multi-energy management. The third one is the consumption forecasting service with artificial intelligence.